Hi, it's Mrs. Pope, and today we're going to be talking about parent functions and transformations. Let me start by saying forgive me if you see my tattoo here that my 4-year-old thought it was a great idea to give me a pickle tattoo while I wasn't paying attention, so just ignore that. That's what that is. Anyway, let's get started. So our goal today is to use parent functions to describe and graph transformations. So we have 4 parent functions that you should commit to memory and know what the graphs of these look like. The first one we're going to look at would be a constant. This could be any number, so we'll just say that's y is equal to a, and I mean any number. So this is the function y equals 7, y equals -4, y equals 25. Doesn't matter. It's just a straight horizontal line, and it's called a constant function. The identity function is one which goes right through the x-axis, and this is the equation for it is y equals x. So if you put in 1 for x, you'll get out 1 for y. 10 for x, 10 for y. So if you graph this, it'd be like 1, 1, 2, 2, 3, 3, -1, -1. So whatever y is, x is, that's called the identity function. Next down here we have the absolute value function, and the v helps you remember what the graph looks like. So it's a v that goes right through the origin and comes back up. And notice it doesn't go below, so when we talk about range later on, there's no negative values here because they're absolute value, and the definition of that is to make it positive, so it makes sense when we look at the graph. So the equation here is y equals the absolute value of x. And then finally, what we're probably most familiar with would be quadratics. These are parabolas, and they have the squared term, so that's how we know they're quadratics. So the parent function would be y equals x squared. So these are the 4 parents that you need to know, and we're going to transform them. Basically, we're not going to use these two very often for transformations. It's really going to be the absolute value and the quadratic. These will have their place later on. But we're going to be shifting absolute value and quadratic functions. We're going to move them, like pick them up and move them right, move them up, move them down, move them left, and we're going to show you how to do that algebraically with the equations. So, I know there's a lot to write here, so you may want to pause right now and write it down, but this is the vertex form. Alright, so for quadratic, we have the vertex form of the quadratic equation. It used to be just x squared, so now we're throwing everything in. Y equals a times x minus h squared plus k. I still know it's quadratic because of the squared. The absolute value is y equals a times x minus h plus k. And notice it's inside the absolute value signs. That's how I know it's an absolute value equation. The a, the h, and the k do the exact same thing for both functions. And as you'll see later on down the year, all functions that we transform, whether it be cubic, cube roots, they all follow the same thing. They have the a, the h, and the k. And fortunately, they all make them do the exact same thing. So for both of these, and for later on, for the a value, if the absolute value of a is greater than 1, so that means, forget the sign, if the number is greater than 1, then it vertically stretches. So your graph is going to stretch up. If you took the y-axis and you stretched it, it's going to make it more narrow or skinnier. If the absolute value of a is between 0 and 1, well, if it's between 0 and 1, that means it's a fraction. If it's a fraction, it vertically compresses. So the y-axis gets shorter, the graph gets fatter. As far as h, if you have x plus h, it shifts whatever h is, 5, 6, units to the left. It's not a typo. Plus h means to the left. Minus h means to the right. Sounds like it would be opposite, but it's not. So as I said, x minus h shifts h units to the right. K, it follows the sign like you would think. If it says plus k, it shifts up. If it says minus k, it shifts down. And our vertex is actually hk. So if you just look here and you grab that number and that number, put them in as an ordered pair, that is the vertex. Notice if a is a negative number, the graph flips over the x-axis, or it reflects over the x-axis. So this is all the information you'll need. Now let's put it together and do something with it. Alright, describe the transformation of this function. So we know it's a squared function, which means it's a quadratic. So now we need to say what happens to it. Well, we see that it has an a value, an h value, and a k value. So tell me what each of those does. I can see that a, that means it's going to Is it going to stretch or is it going to shrink? Remember, if it's greater than 1? And the way we say it, we would say it stretches by a factor of 3. So it stretches by a factor of 3. That's one thing it does. Left or right? Hopefully you said left. It goes left 4 and it goes down 8. That's how you would describe what happens. The things you're describing are the A, the H, and the K. Okay, example 2. I've given a parabola and I put points on there. I want you to write the equation for this graph. So because it's a parabola, we know we're using the quadratic equation, and so the standard form, the vertex form of that, y equals a times x minus h squared plus k. So we know we're going to do that, and we need to plug some stuff in. Well, here, if we have the vertex, we have h and k. And we have another point on the graph, which is x and y. So we can use x, y, h, k. That's x, y, h, k. All we'll be left with is a. And once we solve for that, we'll be able to write our equation. So let's plug everything in. Y is 2. So 2 is equal to a times what's x? Negative 5. Minus what's h? Negative 3. Squared plus 6. So let's simplify that. 2 is equal to a times, be careful, negative 5 minus negative 3 is negative 5 plus 3, which is going to be negative 2. Negative 2 squared plus 6. So 2 is equal to a times 4 plus 6. So I'm going to subtract 6 from both sides. Negative 4 is equal to 4a. Divide by 4, divide by 4. A equals negative 1. Now that we have a, we can write our equation. So the final equation for this one would be y equals negative 1 x minus, what was h? Negative 3, or I guess we should say x plus 3 squared plus 6. So your final equation includes a, h, and k. So you have these 3 values to plug in, and that means you have your final equation written. All right, last board for today. First, I want you to try this on your own. So you don't have to draw the graph, it's fine. Just look here. Here's the vertex. Here's the x, y. I want you to pause now, try it on your own, and then come back, see if you got the right answer. All right, now that you're back, let's see if you got this. I'm not going to go through how to do it. I'm just going to give you the final answer. So did you get y equals, if you haven't done it, you still have a chance to pause and do it, 3/4 x minus 2 squared minus 5. That's what I got. Hopefully you got that too, or either you're wrong or I'm wrong, or we're both wrong. Let me know. All right, last example for today is to graph using a parent function. So here's the equation that we want to graph. Here are the steps. First, we need to plot the parent. Well, it's a squared, so the parent, we know what the parent is, y equals x squared. So let's plot that with like a dashed line. Because this is not really the equation we're graphing. This is just going to help us graph it. So we plot the parent, and let's move to the new vertex. So from the parent, our vertex, or we can tell what happens, it shifts right 5, up 3. So I'm going to go right 1, 2, 3, 4, 5. So move up 5, or right 5, up 3, about right there. So I plotted the parent, check. Move to the new vertex, check. Now I want you to get your graphing calculator. Or you can do it by hand. You can make a table where you'd put x values in and y values. And you'd pick some x values like, I don't know, 0, 1, 2, 5, 7, doesn't matter. I just wanted to get some on the left, some on the right. And you can plug them in and calculate what the y values are. Or you can go to your handy dandy graphing calculator, you can plug the equation in, hit second table, and get some points to graph. So if you do put this in, I don't know if you can actually see this, probably not, but you guys, and I don't know that you even have one at home, but this will just kind of show you what I'm doing. X minus 5 squared plus 3, and we know how to do this already. I would hit second graph, and there's my table. So if I used, let's see, here's some easy ones, 3, 7, 4, 4, 5, 3. So 3, 7, of course this is not exact, 1, 2, 3, 4, 5, 6, yeah, that's 7. What did I say, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. Let me get something bigger than 5 so I can see where that's going to be. 7, 7. So I'm starting to get some points, and you can put whatever points you want on here. I just want at least 4. You can get them from here, or you can make them yourself. Connect the dots, and now you have your graph of your translated function. All right, thanks for watching, and remember, you are responsible for your own learning.